When it comes to object-oriented programming in PHP, there are some definite benefits, and we've just listed out a few of the main benefits to using object-oriented programming. So we're just using it as short there as OOP, object-oriented programming. So object-oriented programming is really good for larger scale projects because you can reuse the code over and over again, and it's essentially designed to help you build faster when you're working on a larger scale. And we say larger projects as opposed to small type applications that you might be building in PHP, where you're not going to be able to really utilize that reusability of the classes, and sometimes setting up those classes on smaller projects, on really small code designed applications, it's not going to be beneficial. It's going to actually take more time than it would. But if you are working on a larger project, and there's definitely a lot of benefits to using object-oriented programming. And as we mentioned before, there are benefits with building up libraries. So if you are reusing code over and over again, if you're developing, if you're a consultant, and you really want to have that code base that you don't want to keep rewriting the same thing, then what you do is you build up libraries, and object-oriented programming makes it really easy to plug these libraries in and get using them and working with them within new code. So the concept would be to develop once and then reuse that existing code. And again, our point here is the reusability of the libraries, so you're able to leverage them on other projects. So once you do create these libraries and you've gone through all the trouble of testing it out and making sure that the code is solid, you get to reuse them as you need to in other projects as well. And this is where object-oriented programming really does shine, because it allows you to have robust code with minimal changes, and you can build out applications quicker and easier, saving you time. And the other main benefit of learning object-oriented programming is the fact that object-oriented principles are consistent across all object-oriented languages. So if you do learn PHP object-oriented programming, you can use the same principles that you're applying in PHP across other object-oriented languages. And that allows you to have the ability to easier understand other programming languages that are based in object-oriented style. So in a nutshell, there's a lot of benefits to using object-oriented programming, and the only disadvantage is that if you are setting up a small project, just the time that you're going to spend to write it out in object-oriented styling, it could possibly take longer than having to just code the code within a procedural method. When you're thinking of object-oriented programming, you got to think of everything as objects. So everything is a separate object, and these objects are used as the building blocks of the object-oriented programming structure. So you're building a bunch of objects out, using them within your code, and that's helping facilitate running your code out and getting application to do what it is designed to do. So the first thing that you have to do when you're using object-oriented programming is to create a class. And a class is what describes your object. Think of it as kind of like a blueprint, and it's going to be something that is going to contain your object and your object information, and you're going to be able to call to that and use that class. So if it's a design blueprint for whatever that particular object might be, you can pull that out. If you think of it as a blueprint for a house, so the house would be the object, and you could create multiple houses using the same blueprint. And if we think of a class like a car, so a car, you could create multiple cars that are going to all look the same using the blueprint, but when you want to actually have some interaction within that car to add additional functionality and describe additional information that makes that car unique and separates it out from the rest of the cards, the rest of the objects that are designed with using the same blueprint. You would be defining different properties that are available within that object. And the properties can be set and manipulated and updated, once again, depending on what the requirements might be. So properties are more of the information that's contained within that blueprint, and you can have access to that and use that depending on what you're trying to do with the object. And lastly, you've got methods. So methods, essentially, it's the same thing as functions, but then they're wrapped within the class. In object-oriented programming, they're referred to as methods. So when you're first coming into object-oriented programming, you can look at the methods as functions, properties as the variables that are available within that object, and both of these are contained within the class. And the class is like a blueprint that's going to help you facilitate and get that information and use that object within your programming structure. In this lesson, we're going to talk about how to set up a XAMPP server on your local machine. So this will allow you to run PHP code right on your local machine. So just like that. So we've got the echo welcome, and we've got welcome being displayed. So if I change that within the source code, you can see that it also changes on the local system. So in order to set this up, we're using XAMPP, which is a free Apache, MySQL, PHP, Perl development environment that you can download for Windows, Linux, and OS X. So just go over to the website apachefriends.org, and there right on the main page you can download whatever version it is that you need to run on your system, so Windows, Linux, or OS X. And XAMPP is probably one of the quickest ways to set up PHP right on your system. So once you've downloaded that, just do an install, and there's going to be some configuration as well, unless you want to use the default XAMPP directory for localhost, which once you run that, you get a XAMPP control panel, and here you can start and stop. Also, you've got some options for admin. You can start and stop Apache, MySQL, FileZilla, Mercury, Tomcat, and it's as easy as click of a button. You've got some configuration options, you've got some logs, as well as you're able to open up the shell here. And then you've got a whole bunch of options to download add-ons for XAMPP as well. So if you're setting up a WordPress, you want to run WordPress locally, Drupal, and depending on what site you want to run, there's a whole bunch of options that you could download and very easily install. And if you notice that my local page is php5.localhost, and my code is sitting within a directory that's not the standard XAMPP directory. So in order to change that, what I've done is on two separate files. So I've opened up the hosts file, which is located at Windows System32 drivers etc hosts, and just gone down and added this host entry. So this is the local host, and I'm just getting the DNS to translate for the local host over to php5.localhost. So you can call this whatever you want it depending on which project you're running, and in order to change the directory for the XAMPP where it's pointing to within the new XAMPP file, there's two lines of code that you have to change, so 243 and 244. By default, it'll be pointing to the XAMPP htdocs directory. So all you have to do is just change that to whatever directory you want to use. So I've got it on my H drive, I've got a folder called websites, and I'm just going right to php5, which is the folder name. And that's where my index is sitting, and that's where it's translating over to the local host. You can as well use the default directory for XAMPP, which is just c XAMPP htdocs. And this is what gets installed by default. So you can see that once you do scroll down, all you have to do is go into the XAMPP and then find the htdocs folder, which is right there. And you can see that by default, if you're not redirecting the main directory, it's just going to have the index page there, and you can also work out of this for your local machine. Don't have multiple projects. If you've only got one project that you're working on in XAMPP, then this would be fine. But if you are working on multiple projects, you might want to repoint your directory. So changing it to wherever your files are located, and remember once again that it is / like this as opposed to a backward slash, because this is local. And also, when you are opening and closing your XAMPP, when you are making changes, you want to make sure that you stop and then restart the server to make sure that it is running properly and that it has taken in the latest changes. Within XAMPP, then you've got some options for configuration. So by default, I'm just using Notepad. So Notepad is a great editor, also open source, so Notepad++. We're going to be providing links to all of these, to Notepad, to XAMPP, within the resource folder of this course. And then you also has options here to specify a browser, and as well as what you want to auto start when XAMPP does start. And some of the reasons for using XAMPP is that it's fairly straightforward. It's really easy to kind of get going and set up. You can download, and once it's installed, you can quickly and easily just start Apache, start MySQL, start FileZilla, Mercury, Tomcat by default, as well as you've got all the options of the add-ons that you can download. But by no means for this course do you have to download this. If you've got another local machine that you're using, you can use that as well for following along within this course. So this is an example of creating a class. So what this class does is we initiate by creating a class, and we assign it some properties and some information here between the curly brackets. And then when we want to get access and use the class within the coding structure, we give it a variable name, we do the equal sign, and we declare new, and we use this class name. So this is always going to be the same, where you're going to be using this class and assigning it this way. So you have to declare a new class to be able to use it, and once it's been declared and a variable has been assigned to it, then you can work with that variable. And here we're just doing a var dump, which is dumping out all the information that's available within this object. So here we've created an object by creating a class first and then creating a new class, which is our new object. And we can work with that object by creating output with it, as well as working with it and manipulating the functionality that's available within that class. So when we go to our browser, the var dump, we see that the structure of the var dump is outputting class property, which is the variable that we're declaring here, and we're going to get into this later on as well, the different. And then there's also protected, so public, private, and protected. And we're going to get into that in a later lesson, what the meaning of those is. So for now, we're just using public, and we're declaring this variable has a value, the string value, and we see it being returned there. That's a string. There's 21 characters within the string, and this is what's being returned from the class property. And as you can see as well, it's within the object. So the object is, when it's created and declared as a new class, becomes an object, and then we can get all that information that's available within that object. And then for the reusability of the classes, you can see here that we can declare another new class using the same class name, and we've got a different object name there, different object variable name, and we can then manipulate whatever information is here within the class as well. And we're just doing a var dump of that out as well. And essentially it's going to be the same thing because we haven't actually anything different between the two objects, and they're going to be outputting the same information. do see the declaration here of object my class, and it's number 2, and here it's number 1. So that is the only difference, and that gives you a little bit more insight about how PHP is treating all of these new classes that are being created with the same class, all these new objects that are being created with the same class name. Within this lesson, we're going to be showing you how to take a value that's available within the class, set it up as an object, and output it within your PHP code. So we're looking at lesson 21.php. We've got our class that we had set up in the previous lesson, and we've done a few changes here where we've set a variable and we've given this variable a value, a string value of I'm a class property, which just to be a little bit more precise, I'm going to say I'm within a class. And we've added in a function within this class. And what this function is going to do is when it gets called, it's going to just return this class variable as a value to, it's going to return that to the object that's calling in that function. So this is a class, we've created that, and this can also be separated out into a separate file. So we're just trying to keep the logic separate outside of the actual coding that we're doing. And then just below, we're creating our object, we're doing new my class, so referring to the my class that we had created here above, and we're setting up our output variable to say object get variable, running the method that's available within the class. So once we've declared it and set that up within the class, then we're able to use all of this information that's available within the class, using it within the object and accessing that information. So we're doing get variable, and it's running this function, and this statement here is understood that this refers to the object. So if we've got a variable that's assigned within this object, we'll get access to it within this format. So the syntax has to be this, and then we do the minus sign, the greater than sign, and class variable. And that works without the $sign. So to kind of think of it that you're adding in this part as you normally wouldn't do within PHP. And that gives you access to that variable and running that function, returning that value there, and it's assigning whatever value is returned from this object, get variable. It's assigning it to the variable output, and here we've just got some standard procedural PHP code where we're doing output. So if output is set, if it has a value, we're going to run this set of code here. So this is just a combination of some HTML as well as some output of the value of output within that HTML, so that we nicely place it within that example area. So providing us this type of output. So example 1, I'm within a class. Within this lesson, we're going to be talking about the different scope options that are available in object-oriented programming. So the scope options, there's essentially 3 different ones. There's public, private, and protected. And in the last lesson, we had a variable that we were defining, property that we were defining, and we just had it defined as a value, and then we were returning and using that value within there. So if you notice, there's actually a shorter way to do that, so we didn't have to go through this method, and we could just simply take this public class and return that, create the new object, and then use that object and access that public class variable and return that as output into our PHP code. So when we take a look at the output, we see that it is actually in fact outputting that information that was available within the class. So available within the object, and it's accessible. And that's because it's defined as public. The scope is defined as public, and that makes your variable function available from anywhere, other classes and instances of that object. So essentially what that means is that as long as we've got an object, we can always get access to public properties, just as we've done within this example. And the reason that we were able to access the function is by default it's going to default to be a public method that's available within this object. So it's the same thing as going public and then calling to that method, and our output should still be the same, and it is still the same thing. So whether you're using a method or a property, by default it's going to be declared public, and that's what gives us that access when we create the object and we get access to the values in there. So in the next lessons we're going to look at what happens when you go private and protected, and we're going to get a little bit more detail about those. In this lesson we're going to be going over the differences between public scope, private scope, and protected scope. So in the last lesson we looked at public scope, and we're looking at the defaults and how public scope uses the methods and properties that are available within that class and is able to return them and use them within any instances of the object. So there's also private scope. So that means when you want to access this information here, any of the properties or methods that are available within that class, this private is going to mean that it's only accessible from within this class. So we're going to be showing you an example of that as well. And protected scope, when you want to make your method or property visible to all classes that extend your class, including the parent class. So that allows you to use that information between extended classes that are only included within the parent class. So you're not going to be having the same functionality as you would with public, but you're not going to be as restricted as you are with private, and you're going to be coming in somewhere in the middle, having access to protected properties and methods that are available within that parent class. So essentially public and private are going to be fairly easy to demonstrate, where we've got it right now set to public, and when we do change this to private, and just show you what happens when we do make that change, that we do get a fatal error, and it says that the private property car blue cannot access the private property. So we've been able to restrict that access to this information just by changing it public, but we are actually able to use this within the class itself. A few updates to the code, and we've got a private property there with a value of 452, and now we've set a public function, and we're accessing that public function or public method through this object, accessing my engine, and it's actually accessing the same property here, the engine size value, but because it's actually within the class itself, it's able to access it by this and return the value that's set within this private property. So because this is public and this one has access to all the private information within this object, we're able to return that value even though it is private. So there's an example of how you can access private information publicly and use that as in the output. But if you did want just access to this, and you might want to just set that to public to simplify things. Here we've updated the code to show you an example of how protected works. So we've added in a new property there. We're calling it protected new engine size, and we actually have access to this when we're using the function within this function. So when we do use that over here, we can see that we do get access to it, and we're going to output that new engine size of 500 just from that value there. So what's happening in that example is we've created the object, we're accessing the method within the object, and because it's protected, or we could access the private one or the public one, we have full access to all the properties that are being set within this class, and what we're doing is we're just returning that protected property. So it works the same way within the class, but the difference is when you are working with protected is when you're extending a class. So here we've done a quick extension of this class, the car blueprint class. We've just called it another car. We've set up a brand new class, a brand new object here, calling it new another car, and we've assigned a value of object A, and here we're outputting object A, and we're calling this method that's available within the new object. So it essentially has access to the information from car blueprint as well as another car classes. And when we do my engine B method, it looks through here, it doesn't see it, and then it looks through here and it says, okay, well, there's that method. We're returning this property, and as you can see, it's not available, it's not set up within this class, but because this class is extending the previous class, we do have access to that protected information. If we were to try to return back a private scope, we can see that we don't have access to it. So we can only access the protected scope that's within that extended class, and from this object we can actually access that original public method as well if we needed to. So we have full access to everything when we're using protected, public, and private in that manner. So we're going to get more into what extends does in another lesson, in an upcoming lesson, but this lesson was primarily to cover off the differences between public, protected, and private, and within this illustration we're able to do that and show all the differences between the different scopes that are available within classes. And it's important when you're deciding what scope you're going to use within that class to look at it and say, what are you going to be using it for? If you need to reuse it in extended classes, then go protected. If you want to have full access to it, then you can just do public, or if you want to have limited access to it only within that particular class. So if we want to have another private one that was only available within this one and we were extending it again, so we would just have to work out the logic when we're creating these classes about what's going to be private, protected, and what's going to be public. And we're going to work more with these in the upcoming lessons as well. So this was just an introduction to public, private, and protected. In this example, we're going to be going over how to change a property value. So within our code here, we've added a whole bunch of new properties and methods available within our original class of the car blueprint. So we created a new public property of gas in the engine. We've got 500 kilometers worth of gas within the engine, and here we've got a method and we're just calling it use gas. So we're taking in a value of the amount of gas that was used. So it should actually be, so this is just going to refer to a value. This minus this is going to return back how much gas there is in the engine still. So what we're doing here is we're just calling these properties and we're working out a calculation. So we're starting with our original gas in the engine, which is 500, and we're equaling it now to that original value of 500, or whatever that value is now, and we're using we're taking in this new value, the gas used value, and we're calculating what that output is going to be. So every time this method is called within this class, it's going to run this calculation and set this value to the new value after it's calculated. So we can continuously access this method and update the amount of money or amount of gas that's in the engine. And here we've added an additional method just to return back how much gas is left within the engine. So all this is doing is this is returning whatever value is available in here. And down within the code down here, so we've got what we had set up before, where we had set up the new object using the class car blueprint. We had gone object, and we're calling in this method where it's using gas, and we're passing in a value of 50. So what this line of code is doing is it's calling this method use gas and sending a value of 50, and we're using this object. So within this object, we've got this method that's called use gas, assigning a value to whatever value is being passed, a variable of gas used, and then we're taking that variable value of gas used and subtracting it from the gas in the engine. So this gives us the ability to drive the car and use gas, and this is in the output area, we're just checking how much gas is going to be left within the engine. So if everything goes well, if everything goes properly, we're going to start off with 500, we're going to run this method, we're going to subtract 50 from 500, and we should be able to, on this check of the gas in the engine, we're going to be able to return a value of 450. And when we refresh the page, we do see that the value is actually there. So if we were to actually add an additional gas use, so maybe there's 2 trips, 1 trip and 2, and we're actually using the same object and using that gas that's within the tank. So watch what's going to happen now. So now we're going to use a total of 200 units of gas, and by refreshing it we see that we do get a value of 300. So what's actually happened here is we've gone here past the value of 50, subtracted it from the gas in the engine, which originally started out as 500. So what I like to do usually is to separate that out and set up the values and properties right off the bat, and then have the methods down here below. And these are methods that are going to be accessing these original values and properties that are being set up. So the reason that we keep it at the top is that we're able to easily see, and if we do have to make some adjustments and we realize that, well, the gas in the engine is not 500, it's going to be 700, we can change the blueprint and update that value, property value, fairly easily and quickly. So what we did is we started off with 500, we made 1 trip, we used up 50 units of gas. So what happened is it got subtracted from the initial 500 units of gas, and then when we made our second trip, we started out at 450 units of gas, and we passed through the same method using up that gas in the engine, and we used up an additional 150 units of gas that was passed through the gas used, and when we do our check here, we see that what's left is the output of 300. So what we can also do just so that we can have a better output and we can see what's happening along the way. See that our first trip ends up at, our tank ends up at 450, and then our second trip ends up at 300. So this is lesson number 24, so within the source files. So if you want to download that and work with that within your local machine and adjust the values and see how that works within object-oriented programming. In this lesson, we're going to talk about constants, and constants are actually available within classes, but they're globally available values that you can access even outside of the class without having to set up a new object to access it. And then, of course, you can access it available within the object itself, and you can access within methods that are available within the class as well. So we're going to quickly take a look at the code here. So what we've done here, we've set up a constant within the car blueprint of constant myColor red. And the way that we're accessing it, we've got our three different ways that we're outputting that same value, and we're accessing it in three different ways. The first one should be familiar if you've watched the previous lessons, where we've got the object and we're doing that minus greater than sign and calling in a method that's available within the object, and that method within the object is what color, and here we do have that method, so it's a public method. There's what color, and it's just returning that color value. The only difference when you are using a constant, we're returning a constant value. So it's no longer a property, the same as what we have down here, and the syntax is going to be slightly different, where we're not including this. We're not doing it within this type of format. We're returning it as self, and then we've got the two colons, and then we've got the value. So myColor, in order to return a constant within the class itself, you have to do it this way. So the self just identifies it as the class, the car blueprint, and remember that constants are globally available, so we only need to refer to self as car blueprint, and if we do actually do car blueprint and myColor, it actually returns the same value. So this is because it's outside of the actual class. We have to reference the class in some way, and the way that we're doing that, we're referencing the class instead of the self that we used over here. We're just referencing the class, and we've got the two colons and then the constant that's available within this class. So just going to look at that for a second, and we're actually doing the same thing over here where we're referencing the constant, and this is just another way that we're actually accessing that same car blueprint, and just that the car blueprint is actually defined as an object, and that object relates to this particular class. So that's why we're able to do it in this format as well. So typically you're not going to be using it within an object, although you can. If you do have constants, you usually would set it in a separate constant class and access them throughout your coding in this type of format. And this just shows that once this constant is set, even though it's available within the class itself, it is still accessible by just referencing the class and referencing the property that you're looking for. So these are the three different ways that we can essentially get the same result, and in all these are three different ways to reference that same car blueprint and property value of myColor and get the value of red returned. Just look at those again quickly, because it is important to understand what the difference of constants and when you may need to use them, that you do understand how to reference them and how to access that information. So initially we're doing object, and this object is already tied to car blueprint, but we don't necessarily need to set up an object in order to access it as we've done down here. But here object is tied to car blueprint, the class car blueprint. So that's understood that we're using car blueprint and we're looking at a constant that's available. This just identifies it as a constant, and we're looking for that constant called myColor. In the second example, we already identified that car blueprint is this class, and this is where we're going to look for that constant. So in this one, we're actually just calling in a typical object and a method within that object of what color, and the difference for constants is how we're returning the this or the self property. So within the class itself, you'd have to write it in this type of syntax where you do self, you do the 2 colons, and again that self is referring to the car blueprint class. It's just that it's inside of itself, and it's looking for this value from my color, returning out red, and then returning this method value to be red. And then lastly, again, car blueprint, we've got the 2 colons again because we're again accessing this class, indicating that we want to look in the class, and this is the constant that we're going to be looking for in the class and that we're trying to get access and we're trying to return the value of. And then the rest of it is just outputting here within our output code. We're just concatenating it, adding it in to our string, and then outputting it within example 1. In this lesson, we're going to talk about a method called constructor. So by default, every single object has this method construct built right into it. And its constructor allows you to initiate your object's properties, give it values when your object is first created. So basically what happens when we go down here, we're going new car blueprint. We're initiating this as an object, and what's happening is all of this is running, available for access within the object. And if you do have a construct, what it does is it actually initializes. So every object looks for this particular method, and if it is available, it's going to run the code that's available within that method. So here we've got a construct. We're taking in a car make, which is a value that we're passing here. Now that we're creating a new car blueprint, we need to pass that in. If we actually remove that, we see that we get a warning message. So we definitely have to, because we're using that now within the construct, that this is going to be a required value that needs to be passed in when you're creating the object. So we're creating a car blueprint, we're creating a Honda as the value that we're passing through. It's running in and creating the object, and when it hits construct, it says, okay, well, this object has construct. We're going to looking for a value that should be passed through from the car blueprint. Over here, it's a required value that needs to be passed through because construct now requires that. If we didn't have this within construct, we would also be fine with doing it this way, but because we're actually trying to use this as well, we can do it this way as well. So if we don't have that requirement within the construct, we can actually set it to just the two brackets. But because we are requiring that within construct, and the object, in order to create the object, it runs construct by initializing it, we do need to have this value pass through. So what happens here is it takes this value, car make, assigns Honda as the value to car make, and then here we've got the coding that we're placing within this method, and we're calling this. We're calling another method that's available within this class called car make, and we're passing over again that value of Honda via this variable value car make. We're passing it into car make method via this value. So this could literally, it could just be, as long as they're the same, it doesn't matter what you're calling it, as long as you're accessing it and calling it back the same way. So by default, I usually like to keep my values, my variable names, the same if I'm reusing them, so that it does make sense for me that when I'm passing it over here, and I can understand that I'm actually accessing it again over here and picking it up. But in this example, it's not necessary. but it's a good practice to get into so that you can refer back to values a lot easier through your code. So here we've got the method called carMake. So this is what we're calling here within the construct method, and we're also taking in that value once again. We're assigning a variable key to it, so it's going to be called carMake, and all we're doing is echoing out the carMake. And that's everything that's being run here. And if you notice once again down here under output, so the output that we're outputting within our HTML code, we're assigning a value to this string, and we've got some HTML in there, we've got some string in there, and then what we're doing, because we've already declared this object, we're using object, we're looking for the method carMake, and we're passing over forward into it. So it's going to look for car blueprint as the object. It's going to look for the method called carMake, and the return is going to be, the code that's going to run is just going to echo that out. And so we're just going to take a look at that, and if you notice, there's something interesting that's happening here. When we look at the source file, we see that it's dropped in that string content that we had attached to output down here, but it's actually printing out the Honda and the Ford right here at the top. And when we look at the code, we see that output is being set to equal this value. And the obvious question is, why is this being output all the way up at the top as opposed to being output and attached into this variable of output? And the answer to that is the way that objects work. And that's why you got to be really careful when you're echoing out content within the logic of your class, because the way that PHP is interpreting this is when it hits echo, it actually writes out the variable information. So whatever is being passed, it's just going to write it out at that time. Because also it's going through construct, it's initializing this, and it's doing the same thing where it's echoing it out. So when this object gets created, it goes to construct, and then it goes to this method, and the method tells it to, okay, echo out this code over at this point. So even if we were to move this down, at that point is where it would be echoing out that content. So wherever we place it is where the content actually gets echoed out. To illustrate that further, I've added in some hello text, and I know the format isn't really great here because I've got the rest of my HTML down here at the bottom, but this is just to illustrate the point that where the code actually falls and where it gets output. And you see that it works the same way as if I was just to put some text in there, some HTML text or whatever we want to do, and I was able to put some text in there, and it functions the same way where it actually outputs that through the browser, and that's how the browser interprets that code, the same way as it would be just written right here in the top. And when it hits this object, when it creates the object, it runs the construct and it outputs the content. And then down here, the same thing. Once it hits this, once this method gets called in the object, it just does whatever is available within the method and it echoes it out. So that's why best practice is usually just to return it. So return this, return the content, and then use that content to output it. So if I was instead to be doing a return of it, which wouldn't exactly work as well within construct, it would output that, it would add that into the string as it has done previous lessons, and then we would see it down here at the bottom. So that's just an interesting thing to note when you are writing out your object-oriented programming, to make sure that you are careful where you're echoing out content and where you're calling different actions within the code to take place. So this is just an extension of the previous lesson where we were looking at construct, and we were looking at the way that the output was being placed. It was being placed at the top of the page. We had an echo within this method, the carMake method, and some of this might have been a little bit confusing because of the values that we were using. Making a few updates to the previous lesson. Within this lesson, we're still setting the variable here, the property here of car make, and what we're doing here is we're actually accessing this value that's available here, and we're setting the value that we got from construct within that. So when we do create that car blueprint, and if we want to make a Honda, we would send over that value into construct. We've got a variable value for car make. We don't have it right now. It's null. There's nothing in there. And over here is where we're setting that value for car make, which is going to be whatever value is being passed through when we're creating the object. And then what we did as well, we updated the function car make to car maker, and it's no longer echoing out that content, it's just returning the current value of car make. So when we look at that, we see that the current value of the car make is going to be returned as car make, and it's going to be, right now, it's going to be whatever value is in here. So when we output our content, when we create our output string, we're calling in that object, we're calling the method car maker, and all car maker now, all that it's doing is it's just taking whatever this value, current value is, and it's returning it back, and that allows us to place it within the output string and place it within our output code here. So when we do refresh this, we see that our example now has Honda, and it's within that our HTML code. So when we look at the source code as well, we see that indeed that code has actually been passed into our HTML, and that original Honda has been set when we're creating our object. And I know what you're thinking, that this is really cool, and this really begins to show you the power of using object-oriented programming, where you can pass through values and reuse all of this content. So right now I can create a multiple instances of the same class, and I can have totally different content available within it. So essentially here we've just created a Honda, and now using that same class we've got a Lamborghini. So truly amazing how we can turn a Honda into a Lamborghini, and here we've just created object B, output B, object B. So we've potentially taken the same code we had here, just added B to it, typed in Lamborghini, and within the output here we're outputting B. And you can see that now we still have access to all of this information, and as we make adjustments to the different values, that property values that are available within the class, you can really see how powerful object-oriented programming can be, and the benefits of making these classes that are going to be reusable and able to plug those into your code and use them and have them output the desired content that you need within your code construction. So here we've got an example where we're actually calling in to those objects and using up some of that gas on the two different cars that we've created. And you can see here within the code we use the same object method that we had used before, where we do use gas, and we set the amount of gas that's being used. And of course our Lamborghini is using more gas than the Honda, and we see that gas left method returns different values because these are two separate objects, and whatever values we're manipulating within these objects are related only to that new object that was created. So this is object, and all that information here, all the methods and properties are related to object, and here we've got our object B, and all of these methods that run through and all the functionality is related to object B. And here we're just printing out the car maker of object B, and we're printing out how much gas is left after we've made a trip, object B. In this lesson we're going to be looking at extend. Now, extends actually provides you a whole bunch of power within object-oriented programming, because the whole idea of object-oriented programming is that even if you want to create another class and maybe there's something slightly different in this class, you don't want to have to be repeating all of this code. So the idea is minimalize the code, and the best way to do that is to reuse classes. So build your classes, design your classes in a way that you can reuse them over and over again just by extending it, and then within that extension you can make the adjustments that you need to make it entirely different and still keep the same basic functionality that you need that you've originally created within that class. What I mean by this is, let's say, going back to the previous example where we had a Honda, we had a Lamborghini, and we have a Hummer. So the Lamborghini and the Hummer are going to use just about as much gas per trip. So when we go down here to the code, we see that it uses 350 units of gas per trip. On one trip, 350. So it's the same as the Lamborghini. But the difference between the Hummer and the Lamborghini is the Hummer has a bigger gas tank. So even though the Lamborghini's used 350 units of gas, the Hummer's used 350 units of gas, the Lamborghini only has 150 units of gas left, whereas the Hummer has 650 units of gas. And the way that we're doing this is we're actually just doing another car and we're extending this blueprint and then running the construct method, which, as we talked about before in a previous lesson, when this object gets initiated, it runs construct, and it's not necessarily related to the construct that's within this object. So we want to be able to set that and use that construct within this initialization. So the reason that we have to do car make again, as we did up here, and it's not going to translate through, is that when we are creating this new object, we need to pass through the car make. And passing that through this way, as well as passing it through this way, so that gives us car make, and we set that car make value in there. And here we've got the other property that we're resetting. So initially within the original blueprint, its gas and engine is 500 units. So we didn't like that, and we set it to 1,000 units. So when this object gets created, it changes the gas in the unit to 1,000 units, and that's why when we still use 350 units of gas on the trip, we've got a whole bunch more gas left. And here we've just got the same thing, so we're using that class method, CarMaker. As you can see here, this class doesn't have CarMaker available within it, but this one does, and this is why, since we've extended it, we get use of it, and we're able to access CarMaker within this format as well. So even if, going back to the public, private, and protected, so even if CarMaker was protected, we would still get this. We would get an error there because of the fact that it's protected. So if we were calling this within this class, we could use protected, but it has to be public because we're only accessing it publicly here. So this gives us the ability to access that class and that information publicly, and if we were to use this method, if we had another method back into the code, you might want to make CarMake protected, and that gives you the ability to use that within the extended class, using it within the construct here. So we're accessing actually this CarMake, and as you can see, I did change that to protected, and when I do go out and I refresh the page, I can see that everything still runs. And we need to keep these as public, these methods as public, because we are accessing them outside of the actual class and accessing them in the object. So we do want to print those out and have access to those. So anything that's being used within the class itself can be private. If it's being used in the extended class, it can be protected. And if it's being used outside of the classes altogether, then it should be public. And then of course, if within another car class we wanted to have additional methods, or customized methods that would only apply to the Hummer, we could add those in there as well. And if we wanted to have only methods that worked within the original class, we would add them in here and we could refer to them as public. But if we want the methods to go across both classes, the extended classes as well, then we would have to go with protected or with public, depending again how we're looking to access it. So there is quite a bit of planning when you are creating your object-oriented structure, and it is important to take a look at this and see which ones you're going to be accessing within the planning of your application to make it work efficiently, as well as planning out which parts of the class, what you want to extend within the class, and what you're going to need to reuse, and what code you're going to have to write off of the original code that you had within class. So whole idea, keep it at a minimal, but also plan it out well so you can minimize the amount of code that you're doing and still get the same results that you're looking for when you're creating your applications. So as you can see in the previous lesson, when you're using extend, you've got a whole bunch of new options that you can allow within your object-oriented programming. So here we've set a type of the vehicle. So we've got car, we've got Lamborghini as a car, Hummer as a truck, we've got color, so color blue, red Lamborghini, and a yellow Hummer, and then we've got from the previous lesson the gas lift. And the way that we're doing this, we've added quite a few additional methods. So one to set the type, one to set the color. We've got the setting of the properties, so we're setting car type and car color, and then we've added methods in order to make adjustments to those. So we can set those once we create an object, and depending on what we're doing with the code, we can change these properties within the object using these types of methods. And then over here, it's still returning back that same method and returning back the value. So if you notice within the code, we're actually not using methods. We're just calling over to the property and object, again, created here using this class, and we're passing that initial car maker there. So we could also set up in this format where we're customizing for each individual one, where we've got a car, we've got a color, so we've got a type and we have a color, and then we can return those back just as regular object properties. So we've got car type, so we don't need to have a method in order to return back those values. We can just use that car type property and return back that information. So if you don't actually set this information, you're not going to get an error, but you are, because those are still going to exist as we've defined them here. So they're going to still exist within the object, and you're not going to get an error thrown, but you're going to see that they do get returned back as null. And so this is important to note as well, that it's not required that you have these properties within an object, but it does give you the option to add them. And again, it comes back to the planning of your object-oriented programming and how best to plan it out so that you can accomplish the actual application logic that you want to be able to return back to the web application itself. So here within our example, once again, we set those, and we created methods to set the different properties, and here for another car we just extended that initial class, and we had set some of the properties, customized property values here as well. So when we do create another car, or we should say that maybe this should be create a truck, because it's always going to have a gas engine size of 1000. So we can see that it still works in the same way, and these are just different ways of really accomplishing the same thing. You could very easily just set car model or car maker within one of these objects as well, and then return it and set it through a method, setting up a property, returning it through a method, and then outputting it within your code. So depending on what works best, what you need to do within the planning, you can structure it in several different ways, and the whole idea is just to be as efficient in the output as possible and to minimize the amount of coding that you're doing, so you're not creating a whole bunch of lines of code that are essentially doing the same thing. And this code can be downloaded in lesson 29 PHP file. So I do encourage you to go take a look at this, play around with some of these values, and just see what the outputs change. See if you remove something, maybe throw an error, and rewrite it in different ways in order to produce similar type results as I've done within the coding that I've outlined here within this course. Again, the best way to get to know and to understand all the way that object-oriented programming works is to practice. So it is encouraged that you download our source files and work with them, practice with them, and see all the different functionality that you can get out of the code that we've provided.